I'm gonna explain my dad.
All right, so we're going to start section 5.1 today, talking about nth roots and rational exponents. Rational numbers are fractions, right? So we're going to have fractions for exponents. Okay? So we're going to evaluate and solve equations containing nth roots and rational exponents. All right, so it says you learned that the nth root of a is the same as a to the 1 over n power. Okay? So if I have this problem, what root is that? What do we call that? Square root, right? So what fraction is that for 1 over what? Because it's a square root. 2, yeah. When you square something, you take it to the second power, right? So that's what that's saying. All right? If I have a cube root, that's 8 to what power? 1/3. Yeah. If I have a fifth root, that's 1/5. You guys get any idea? Okay. So we can write roots, nth roots, with rational fraction exponents. Okay? So that's what we're working on today. All right. So I have the square root of 5 to the 3rd power this time. All right? So the base is 5. Since it's square root, what's the denominator? No, square root, what's the denominator? 2. All right? Since it's to the 3rd power, what's the numerator? 3. Okay? So we call this the index, where you see the 4 and the 3. If you don't see a number there, it's square root. The index is 2. Okay, we just never write the 2 for square root. All right, so this base is 4. The denominator is the root, or the 4, and the numerator is the exponent, 2. But what's that reduced to? 1/2. So that's like the square root of 4. So the answer would be 2 if we actually found the answer, right? So what's the next one? Landry, 9 to what power? Well, where's the 3 go? And where's the 2 go?
Okay.
Yeah, what's that fraction? 2 over 3, good. Mason, base is 10. What's the fraction for its exponent?
4/5.
Right, 4 over 5. Caitlin, the base is 15. What's our rational exponent, our fraction? Good. You guys get any idea? Any questions? Emma, you with us? Okay, what's the next one, Emma?
27.
Yeah, 4 over 3. The exponent is the numerator. The root, the index, is the denominator. Okay, let's go the other way. What's underneath the radical sign? 8. What's the exponent? 2. What's the root? 3. Very good. So we have the roots be 6. 5 is the exponent. And do we need to put a 2 there? No, but you can. If you do put the 2, it's okay, but you don't have to. Sydney, what do I do here?
With the 4, like over, I'll put the 12 on the left side.
Okay,
3 on the outside, and 4
good. Vincent?
Yes. Let's see, 10 underneath this sign and, hold on. 3 on the left, or, right? Yeah, 3 on the left and then 4, or,
Well, look at this one.
oh. Yeah, 3 on the outside. And
Yeah.
2 on the inside.
2 on the inside. We don't have to write it, but if you do, it's okay.
Oh, okay.
AJ?
3 on the outside.
Good. Mr. Berkey?
Okay. You have 5 in the inside of the radical, 20, and then the 6 on the outside.
You guys get the idea? Sounds like it. Good
Yeah.
job.
I was a little bit.
Is that it?
Now you're not though, right?
It was easier the other way.
Yeah, it's easier going the first way than back. All right. So it says you can extend this concept of a square root to other types of roots. For example, 2 is a cube root of 8 because 2 to the third, or 2 cubed equals 8. In general, for an integer n greater than 1, if b, the base, to the nth power equals a, then b is an nth root of a. An nth root of a is written like this. The n's your index, a's the, we call that the radicand, right? N is called the index. I've been telling you that already, right? The index of the radical is the root. Okay? It says you can also write an nth root as a power of a. If you assume the power of a power property applies to rational exponents, then the following is true. So a to the 1/2 squared is 1/2 times 2, which is a to the first, which is a. All right? Which is a to the 1/2 is like the square root of a, right? The square root of something squared is itself, right? So that's why it comes out to be a. This is like cube root. So a to the 1/3 cubed, all I'm doing is multiplying 1/3 times 3, which is also a. Or the cube root of something cubed is itself, right? Same thing here. A to the 1/4 power raised to the 4th power means I multiply the exponents, which I get 1 again. That's like the 4th root of a to the 4th power is itself. Okay? So that's what they're saying there. All right. So, key idea. All right? When the index is even, like square root, or 4th root, or 6th root, or 8th root, that's what they're saying. When that's even, and your radicand, the number under the radical, is less than 0. What are numbers less than 0 called? Negative numbers. You can't do it. There's no real roots, right? That's when we started doing the imaginary roots, remember? So there's no real roots if we have an even index and we have a negative number. If our radicand, the number underneath the radical sign, is 0, no matter what the root is, the answer is 0. If you have a positive number under the radical sign, okay, then you have 2 real roots. You have to use your plus or minus symbol. And we did that when we did equations. If we had this equation, x squared equals 25, what did we do to solve it? What did we do to both sides? We took the square root, right? And then, like AJ just said, we had to put the plus or minus symbol. Well, when it's square root, it's an even index, right? So that would hold true for a fourth root or a sixth root. We have to use the plus or minus sign. Okay, there's two real roots. Okay, if your index is odd, like a cube root or a fifth root or a seventh root, okay, if it's negative, there is one real root. It'll probably be a negative number. Okay, if it's zero, it's still zero. If it's positive, so for an odd integer, there's only one real root for each type. Negative, positive. So if I did the cube root, or let's say x cubed equals negative 8, all right, what would I do to solve that? I would take the cube root of both sides, right? Well, that means what times itself 3 times is negative 8. Well, negative 2 times negative 2 is a positive 4 times another negative 2 is negative 8. So there is, when it's an odd index, 3 is an odd number, and we have a negative number under the radical sign, there still is an answer. There is still an answer on that. Okay? That's what they're telling me on that key idea. Even index, negative number, no real roots. Whenever there's 0, even or odd, the answer is 0, right? When it's even and you have a positive number under the radical sign, there's 2, a positive and negative answer. For the odd ones, there's always one real root. Okay? Odd index, whether it's negative, 0, or positive. Okay? All right. So find the indicated real nth roots of A if there's more than one. So this is asking us to do the fourth root of 81. All right? So just do what we did in the past. Do a factor tree. But since it's fourth root, I'm looking for a group of how many? 4. So do I have a group of 4? Yeah. So what's that answer? 3. Since it's even, and that's positive, we could say what? Plus or minus. If I did negative 3 times negative 3 times negative 3 times negative 3, I would get a positive 81. Okay? This one, I'm looking for the square root of negative 49, right? Are there any real roots? Real roots? No. In the past, we're saying what's that answer? 7i, right? That's a non-real, right? That's an imaginary root. So this one, if you have an even index and a negative number, no real roots. You with me? Yeah, so this is just asking, find the indicated real. It's looking for real roots. There isn't any for that. We know there's an imaginary one, right? But there's no real. Okay, this one. We want the cube root of negative 125. All right? So if I do a factor tree, is negative 5 times negative 5 positive 25? Yeah. I'm looking for a group of how many this time? I'm looking for a group of 3 this time. Do I have a group of 3? Yes.
Oh, yeah.
So this answer is negative 5. There is one real root. Is this making sense?
Yeah.
Okay, so this is an odd index, 5 and 243. Now here's a trick if you want to do factor trees. What's 2 plus 4 plus 3? 9. That means 9 will go into it. If it's a multiple of 9 or a multiple of 3, when you add the digits, that means that number goes into it. So I'm going to do 9. And 9 goes into 24 twice, right? And what's 24 minus 18? 6. So what's 9 into 63? 7, right? 9 times 7 is 63. So that's 9 times 27. What times what is 9? What times what is 27? Is there a group of 5? Yeah, 1, 2, 3, 4, 5 threes, right? So the answer is 3. AJ.
Adding things only works with 9 and 3.
Yes. Yes. That's a little trick. If you're trying to do stuff in your head, you want to know if 3 goes into a number or 9, add up the digits. And if you get a multiple of 3 or 9, it'll go in. Yeah. So far, so good? You guys are doing a good job. All right, rational exponents. A rational exponent does not have to be in the form 1 over n. Other rational numbers, such as 3/2 and -1/2, can also be exponents. So it says 2 properties of rational exponents are shown. All right, so a to the m over n power is the same as a to the 1 over n times m power, or the nth root of a to the nth power. All right, so we just did that anyway, right? In that first slide we were doing, you guys saw how we could do that, right? Now remember, if we had this problem earlier this year, what did we do with that? We didn't like the negative exponent. So where did we move that exponent? To the ground or the denominator, right? Below? Yeah. Those are the same. Okay? We said we would do reciprocals when we solve stuff like that. Okay? So that's what that's talking about when you see the negatives. That's why these became 1 over. All right? So 16 to the 3/2. All right? So the denominator is the what? Isn't this what we just learned earlier? Well, you guys know what the square root of 16 is. What is it? 4. So this is 4 to the 3rd, which is 4 times 4, 16 times 4, so that equals 64, right? All right, so this one is the cube root, because the denominator is the index, right? Well, what did we just learn about the cube root of 64? It's right in front of us, right? So this is 4 to the 4th. So 4 times 4 is 16, times 4 is 64, times 4 is, what is that, 256?
Yeah.
Making sense, William? Now, what do we do here since it was negative prefix? Make it 1 over 32, the 5th root to the 3rd power, right? Make it positive, though, then. Now, if we're not sure here, we could go, 4 times 8, 2 times 2, 4 times 2, 2 times 2. What do we see? 5 2s. So what's the 5th root of 32? A 2. So this is like 1 over 2 to the 3rd which is 1 over 2 times 1 over 2 times 1 over 2, which is 1 over 8. Making sense? Again, we had to put it 1 over because it was a negative 3/5. Okay? We got to do the same thing here. 1 over 16. What root? Fourth root to the positive 5th power, right? Well, that's 4 times 4. 2 times 2, 2 times 2. So what's the fourth root of 16? 2. So this is 1 over 2 to the 5th. So what's 2 times 2?
4,
Times 2
8,
times 2
16,
times 2.
32.
Simple, right?
Yeah.
What'd you find out, Nolan? Oh, did you hear that?
How do we put on the bracket?
Okay. So it says using technology. That means you can use your what? Calculator, right? So so how do I raise something to a power?
Carrot.
Caret, right? And then the fractions, if you have an older one like me, you have to put it in parentheses. If you have a newer one like Sophia does, it'll show you, it'll put it up there for you. You just put 1 divided by 5. Okay? But if yours is like mine, I have to do parentheses 1 divided by 5. Like that. Okay? Round your answer to 2 decimal places. So that's what? What's that to 2 decimal places? 1.55. Okay? Go ahead and do B.
That's such a weird emulation.
All right? 12 to the 3/8 is 3 divided by 8. So 2 decimal places is what?
1.54.
2.5.
Or
Right?
2. I don't know, I read something before.
So it's a 4, not a 3, right?
I'm not dumb.
We understand that, don't we? Okay.
Caleb was.
Anybody having issues with their calculator?
Nope, no.
All right, so how do you do that? Well, you could rewrite it as 7 to the what? What's the fraction? What's the exponent fraction? Is it 4/3 or 3/4? The index is always the what? The denominator, right?
Yeah.
But you can do this too, if you want. I'll show you. Okay, pay attention. Now, mine, since it's 4th root, I have to hit a 4 first. Some of you won't. Okay? If you have the newer calculator, I don't think you have to. But you have the older one like me, you hit 4, then hit math. In number 5, means you're putting a 4 where that X is. 7. Then I would just hit enter and then go to the 3rd power. Like that. Okay? So you have to hit math to get number 5 there, the X index. There's cube root there if you want 4. Math. Right here. If you have a newer one, I think you can just go to that. Is that right or no? You don't know?
I think I just have a button to it. It's
You still have to do the number before?
N radical x.
No, I didn't do it. All right.
Burger King with a white zone.
You have an older one.
Hey, look, Ricky in the gaming shirt. Is that, if that's how you see me now, I'm sorry.
Yeah, I guess you do, huh? Yeah, so either one, I guess you have to put 4 first. Whatever the index is.
You're lying. You're just lying.
All right.
Like AJ and Jimmy.
Solving equations. All right?
I don't look dead. I look hollow. You're not hollow. You're screaming.
Remember, if you have an even index and it's positive, you got a plus or minus symbol, right? When we solve, just like we did before with quadratics.
Or homework.
There we go.
Oh, curveball. No homework. No.
Before we get to homework, I want to go over this. Before you do this, fifth root, you got to move the 4 over. You got to get the x alone. So you need to do this part first. So it's just x to a power. What's 128 divided by 4? 32? Okay. So we're going to do the fifth root, right? Or you could write this as 32 to what power? The fifth. Not the fifth power. The 1/5 power.
1/5.
Okay? So, is this an even or an odd index? Odd. Do I need to worry about plus or minus then? No. Only on the even one. All right? And what do you guys get? 2. All right? The more you guys do these, the more of these you'll learn to do in your head. Do I need to move anything over to the other side for this one?
Yeah, probably. My luck.
No. There's nothing in front, right?
I guess not.
Here we had a 4 in front of our base. Our base is x. What's the base for this one? That whole thing, that x minus 3 is the base, right? Because it's in parentheses.
Yeah.
Okay. So what do I do to get rid of that 4?
Yeah.
I do the 4th root, right? Or if you want to think about it like this and raise it to the 1/4 power, because that's what we end up doing anyway, right? That's the same thing. Okay? So what's the 4th root of something to the 4th power? Itself, right? We had that with square roots, right? When we did completing the square stuff. So you can take the 4th root of 21, or you can go 21 to the 1/4 power. If I'm doing the 4th root, I hit the 4 first, math, number 5, 21. I like to close it up. I didn't. I put it through. I did 3rd root, didn't I? Sorry. Let's clear that out. So I need a 4 for the 4th root, math, number 5, and then 21 to get that answer. So that's 2.14. So what's my answer to finish? 5.14. I have to add the 3, right? You guys know we still have to do that, right? Okay. Those make sense? So get the part that's being raised to a power alone first before you take the 4th root or 5th root, or take it to the 1/4 or the 1/5 power, or whatever you have to do. I think that's it for examples. All right, there's your homework.
Cool. I thought
If
it
it'll
was
go.
baseball for a second.
So some evens,
Fry is drawing.
it's not as much as the looks like. And it won't take you that long, because you guys are pretty good at this already. Sounds like to me. You guys did a good job.
I mean, I hope I don't